Good morning, students. Today we are going to learn projectile motion. This is one of the important topic which is having vast applications. Okay. Then first we have to understand what is a projectile. Okay. Then we understand what is the motion of that projectile and how it is going to take place. Okay. It is an example for two-dimensional motion. Okay. Then coming to projectile, a body which is in flight after it is thrown or projected up is called a projectile. That is, a body in traveling in air is nothing but a projectile. Okay. We can see so many cases. Okay. A body which is thrown from the ground with certain angle to the horizontal. Otherwise, it is going to travel in a horizontal direction in a single line. Okay. That is, it has to make some angle with the horizontal. Okay. With some velocity. Then it goes and falls down like this. A body which is thrown horizontally from a building, or a body which is thrown with some angle with the horizontal from the top of a building, or a body which is thrown from an inclined plane with some angle or even horizontal. Okay, all these are examples for projectiles. Okay, or a body which is thrown straight up into the air. It is a vertical projection. Okay, it is one of the cases. Okay, now that is the meaning of projectile. Generally, we take a simple case where we take a horizontal surface and we project the body with some angle to the horizontal theta with some initial velocity v naught. Then, if we throw the body like that, then what happens means, to understand this one, we have to divide this velocity into two components. One is horizontal component and another one is vertical component. Okay, as it is making theta naught with the horizontal component becomes v naught cos theta naught. Okay, and the vertical component becomes v naught sin theta naught. Okay, then if we take these two components, then on the horizontal component there is no action of this acceleration due to gravity. Only this acceleration due to gravity, it is going to show its effect only on the vertical component. That is, through the motion of the projectile, the horizontal component is not disturbed. Only vertical component is going to be disturbed. And to consider this case, we are taking an ideal situation where there is no air resistances or frictional forces on the body. Okay, that is, first we are speaking about an ideal case where there are no frictional forces or no air resistances on the body. Okay, that is, see here. Initially, we are going the body with a velocity v naught. We are dividing this one into two components, v cos theta and theta naught, and v naught sin theta. Okay. Then the acceleration due to gravity is just acting downwards, minus g into j cap. We are taking I coordinate along x axis and j coordinate along y axis. Ax is 0 and ay is minus vox, initial velocity is v naught cos theta naught, v over initial velocity, v naught sin theta naught. And we are, for our convenience, we are taking the body starting from origin. That is, x naught initially, there is no horizontal and vertical displacement. Then we can write the distance is equal to velocity into time. Horizontal distance is equal to horizontal velocity into time. Okay, v naught cos theta naught into t. Then vertical distance or displacement is v naught sin theta naught. That is, s is equal to x is equal to v naught t minus half gt square. Here it becomes, we have to take only vertical component, v naught sin theta naught into t minus half gt square. Then at any point or at any position, the velocity becomes vx, okay, horizontal velocity vx, and initial velocity is v x. We write that one as v naught cos theta naught. That vy is equal to v naught sin theta naught minus gt here. Here it is, as it does not depend on acceleration due to gravity, it remains constant throughout the motion. There is no influence of anything on that one. It is away from that. There are no frictional forces, okay, and there is no air resistance. That's why this v naught cos theta naught, okay. Then this becomes minus gt. Theta is equal to, that is at any points of its journey, this tan inverse vy by vx, okay. That is, if you take at any points of its journey, okay, theta becomes this vy minus vyx or vx, okay. For the sake of simplicity, we write this one like this, vy by vx or vy by vyx, okay. Then equation of path of projectile. Now after understanding this one, that is, if we divide the initial velocity into two components, vertical component and horizontal component is going to remain constant throughout the motion. Only vertical component is changing. See here, like this. Initially the vertical component is like this. If it travels, it becomes, and at the highest point the body travels like this. The tangent at that position is in horizontal direction. All these are tangents. These velocities are tangents. At highest point it is around the horizontal, where this velocity becomes horizontal component and there is no vertical component. That is, at highest point there is no vertical component for velocity, and from that point it falls down like this. While coming down, this vertical component changes its direction. Up to this point it is in the upward direction. From this point it points towards the earth direction, that is vertically downwards, okay. Then equation of path of projectile. What is meant by path? It is just the trace or the line followed by the body, okay. Suppose, what is the path of a train means? A railway. What is the path of a bus means? Road. Whether the bus is there or not, if it has to travel, it has to follow the road. Whether the train is there or not, if it has to travel, it has to travel on the track only, okay. That is, the track or the road is the path followed by the train, okay. That's why we consider this line as the path followed by the projectile, okay. If we throw the body, okay, into a projectile motion, then it is going to follow that path, whether it is there or not. That is, the meaning there is, it is irrespective with time. That is the meaning of path forward, okay, irrespective of time. That is, if we eliminate time from these two equations, we can get the equation between x and y, where there is no time in that equation. That is called as path of the projectile. For that one, we take these two equations. At any position, the value of x is given by v naught cos theta naught t. Y is given by, at any instant of time or at any instant of time, these are the two equations. Y is equal to v naught sin theta naught t minus cos g t square. We call this as equation 1 and 2. We have to eliminate time from these two equations. That is, by using first equation, okay, we use first equation for time. T is equal to, we can write t as x by v naught cos theta naught. That is substituting equation 1 for t, okay. in equation 2, we get V naught sin theta naught. Instead of t, we are keeping x by V naught cos theta naught. Okay. Then substituting this value, minus half g into, instead of t, x by V naught cos theta naught whole square. We get y is equal to tan theta naught x minus g by 2 V naught square cos square theta naught into x square. Okay. Now, if you see this equation, this is in the form of a parabola equation. Y is equal to kx plus bx square. That is, the path of projectile is a parabola. Okay. It is going to have a path similar to the parabola. That is, the path of projectile is a parabola. Okay. We have to understand so many things. See, initially the horizontal velocity is going to remain constant. Only the vertical component is going to be changed. At the highest point, we are having only horizontal component for velocity, that is equal to the horizontal component right from the beginning. That is from the initial stage. It is going to remain constant. The same value is there. Only it is changing. Vertical component is changing. Okay. At any point, if we resolve this one into 2, we can easily analyze this one. Okay. In this way, we understand the meaning of a projectile and the path followed by the projectile. Okay. Only the acceleration due to gravity is influencing the vertical component. That is, we are considering the particles that are under the action of gravity in this state. Okay. We are just taking the influence of the earth on these types of bodies. Okay. We are not going away from the earth. That is, we are just bound to only terrestrial objects. Okay. That thrown which are under the influence of gravity. Okay. These types of bodies are called as projectiles, and this is how we understand the path of the projectile, and this is how we are going to analyze each and every component. Okay.